Yeah, it's a pleasure for me to do that, although I'm a little upset with Rita because I told her she needed to explain to you all my qualifications. I'm an old fogey and very proud of it. If you do it right, life gets better the longer you're at it. It is a pleasure for me to introduce Peter today. You can see by his first slide that this is a very distinguished computer scientist. So what I'm going to say is not on the formalities, but more a personal note. What you don't know, but you should know is Peter's been infected with the archival bug. And as we all know, there's no known cure. Once you get interested in archival problems, you're there for life, which is NARA's good fortune, because we succeeded in infecting him several years ago, and he's been doing, let me start with the word very interesting things for us. Sometimes the interest could be conceived as a curse. And part of what you're going to hear from Peter today is rather disheartening for ERA, because from the perspective of an old fogey who's been working with electronic records since 1975, I say probably the biggest problem we have in NARA with electronic records is actually the number of formats that these things come in. And the number of formats is only increasing over time, and the formats get more and more complex. So from 1970, when we brought in our first accession of electronic records, till essentially today, the National Archives has been self-limiting because we would not accept accessions of records if we couldn't deal with the transfers. The presidential libraries haven't had that luxury. They have to take whatever the White House throws over the fence at the end of administration, but our ability to do our basic job has been limited by the fact that archivists like to be really good at what they do, and so if we couldn't handle the format, we just wouldn't take it, and therefore we didn't take many formats. Well, the bad news about Peter's presentation is that he's going to show you that in areas like 3D representation, there are dozens and dozens, in fact, over 100 different formats. The good news about it is we got people like Peter Vaji working on this issue and finding ways that the technology can help us with a lot of the basic problems that we have with formats. And we need the technology to do for us whatever it can so that we as archivists can do what we need to do in our profession. So it'll be really good news when you hear the kind of tools that Peter's been developing. So welcome.
Thank you very much, Ken. So as Ken said, it's very true that I have been infected with this archival bug. I have been coming here for more than, I would say, 4 years. And every time I come here, I'm fascinated with the problems that you guys are facing. And I'm a computer scientist, so I don't know too much about archival issues, but every time I come here, I learn something, and then I kind of thank my collaborators for educating me, and then we kind of go home and try to kind of address those issues. I also want to say that this is a long week. Ken and Bob Chaddock also came to the NIST organized a workshop, which was this week from Monday through Wednesday. And what I have learned when I presented some of the work that I'm going to show today is that it's not just the National Archives, but there are more or less many communities that face very similar challenges that you are facing in your daily job. And then they are trying to come together, you know, like the Library of Congress, the Smithsonian Institution. We talked to several people from museums, from state archives. Actually, 2 weeks ago, I visited the Archives of American Art. Many of these people are coming together and saying, well, look, there's just so much work to be done, and we have really challenges that should be overcome jointly. Very simply, and I'll show that today, there is simply no way that a single person or a single institution can undertake such a large effort as we are facing right now with digital records. So you're probably tired of listening to all these introductory words, so let me show you something that might be directly applicable to your maybe daily life. I would like to start giving the credit to our sponsor, and I also have to say that all the slides that I am going to present are, this is a disclaimer, are just my opinions, and the contribution to this work came from multiple people who work on this project over the past several years. I'm going to introduce the problem of really a very simple problem. How do you keep your files current? And kind of go over the technologies that we developed for you. I will present all the work, and I will try to do that from your perspective. I'm not going to talk about the nitty-gritty details of the computer science, but I will rather try to show you how these tools might be applicable in your daily life. And then try to summarize where we stand and how you can use it or what we plan to do. So, why are we trying to look at these problems? As you know, according to the strategic plan of the National Archives, one of the major goals is really to improve the efficiency with which we manage our holdings from the time they are scheduled through accessioning, processing, storage, preservation, and public use. And I was I was fascinated with that goal because when I talked to Bob Chaddock, for example, he's telling me we have to manage our holdings until the end of the Republic. And when I went to the NIST organized workshop, there was a gentleman from the Library of Congress, and he says, it's not the end of the Republic, but it's 4,000 years beyond the end of the Republic. So whether it makes a difference, I don't know, but it's a long time, I have to say. So here is the overview. This was, when I was introduced to this problem, I was thinking, man, what would I do if somebody comes with a pickup truck or a big semi or a dump truck, just dumps all the DVDs and CDs in front of my door, and my task is to figure out how the files are related, which ones are relevant, and then what to do with them in order to preserve them maybe just 100 years down the road. And so how would you even go from that dump truck, and you have coming these trucks from multiple agencies, and then you are going and sorting, going through all the files and then figuring out how things are related. Well, do we know the answer? So the first question is, I'm not going to talk about it today too much, but we looked at the problem, what should be the granularity of information that one should preserve about the decision process in order to reconstruct it. So for example, a historian would like to know 100 years from now, why did we go to Iraq, right? And then there are some records, and then we would like to know what should be the granularity of the information that we preserve today in order to reconstruct the decision process. And so we looked at some of these problems and what are the implications on storage and computational requirement and costs, right? Because if I increase the granularity of information, it's going to cost me more because I have more data to store, and it might take more computation to reconstruct than we have a prototype. Then we look at a different problem. I give you thousands of DVDs with files, and I will ask you which files are related. Just tell me how they are related. And one of the examples that we worked on was we had 2D, these are on the right side. I think my pointer should work. Oh man, it doesn't work. On the right side, you see these are engineering drawings, 2D scans of blueprints. On the left side, you have 3D CAD models. And you would like to find the file correspondence. And we have processed about 784 TIFF files and about 30 3D CAD files and build this framework where you can see and discover the relationship among these files by what we have done is we did the optical character recognition of the title blocks, extracted the metadata, show it to you in this framework, and then the same we did with the 3D CAD models, extracted the metadata about the creator and the file type and so forth, automatically presented to you, and now you can see the relationship. Another question that we have looked at was, given hundreds of versions of the same file, which file version or versions are similar, and which ones should be preserved? So for example, if you received the White House report, and there were, let's say, 20 different versions, which version is similar, or what were the changes, and then which ones should be preserved? And what was really difficult in this problem is that if you, let's say, look at Adobe PDF files, and again, I may be introducing new terminology here, but they are not really files from my perspective. They are containers. Because inside of that Adobe PDF file, you will find text, you will find images, you will find raster graphics like tables, you will find animations, you will find 3D CAD models. So suddenly, the comparison of these Adobe PDF files becomes very complicated because you have to extract first, let's say, all the text components, and you start to compare them one by one. Then you extract raster or images, and then you start to compare them, and then the vector graphics object. And then as you do all these comparisons, then you have to figure out how similar are the Adobe PDF documents as a whole. And then you try to order them either chronologically or based on similarities. Okay, and then the fourth question that we looked at was, given thousands of file formats, which conversion software to use and which target file format to use so that the content of those thousands of files would be viewable in the long run. And as you know, when you receive, let's suppose, let me give you a good example. I was told, and this is an unofficial number, that the federal government is using about 60,000 file formats. Now, I'm not sure whether the number is right because I couldn't find it on the internet, and if Professor Google doesn't know, then nobody else knows. But you might know how many file formats you are dealing with here at the National Archives. But this problem on its own, if you have, let's say, thousands of files, and you would have to make a decision into which file format I'm going to convert everything because my financial constraints allow me to preserve only one file format. Which one would you pick? And which software would you use? Because, as you know, different implementation might have different quality. So this would be the focus of today's talk on some of the examples of technology that would provide answers to this question at large processing scale with computational scalability. Okay, so file format conversion. So what did we observe? It's definitely one part of our daily life, and it's really inevitable. The question is, can file format conversions assist in making digital content created today to be accessible and viewable throughout its life cycle? And we don't know what file formats will be around 100 plus years down the road, or we don't even know what will be, let's say, 50 years down the road. But what we ideally would like to do is to make these files backward and forward compatible. And I think many of you probably have come to the conclusion that in contrary to the past, when you deal with electronic information, everything is very dynamic, right? You know that you had some, you put your bytes on a floppy disk and you thought, oh, this is safe. Well, not anymore. Now you have CDs, DVDs, and so forth. And so how do you really keep your media current? How do you keep your file formats current? You really have to figure out how to make them backward and forward compatible. So the problem of file format conversion is also difficult because there is a very large number of file formats. And there is an increasing number of file formats that have a very complex, or they have multiple types of digital objects, like I was talking about Adobe PDF, that it has text, images, and vector graphics. If you know something about the NASA preferred file format called hierarchical definition file, HDF, it can contain anything. It's like your folder. And some of the file formats have, let's say, the file format step for 3D CAD models. It's about 1,200 pages specification. So very complex. Many software implementations of import or the read and export operations. So many of them, there are many of those implementations. And they have different quality, right? So if you have a bunch of graduate students that write some kind of a reader, probably is not as good as if a vendor provides the software implementation. And as we know, while I'm giving this talk, there are probably tons of file formats being invented out there because there are small startup companies. They want to keep the content proprietary, and they will come out with their own file format. And then after, I don't know, 10 years, they go out of business and nobody can read the information. And finally, just to let you know, there is also dependency on hardware, right? So many of these software implementations are tightly coupled to certain architecture or certain computer hardware. Okay, this slide just shows what I mean a 3D format reality. And I can go forever. You can see how many of these are there. These are different software packages and file formats that are in the 3D file domain. And we have published a survey where we documented more than 140 different 3D file formats. I think about 16 different software packages, commercial software packages. And you can see that I can kind of put it together and then say, well, what am I going to do? I mean, if I want to use tool A and it has some functionality, I have to convert it to format B because that other software supports only a subset. So how am I going to do that? So my challenge is really that when I'm dealing with these software packages and multiple file formats, I don't know the quality of file format conversions. I don't know that prior using that software. The volume of file format conversions requires significant computational resources. You might not realize it, but if you have millions of files, it will take maybe significant computer resources. And then when you do the file format conversion, there is always some information loss. Actually, we have shown in the past that there are some paths with 3D CAD models where you start with a CAD model of a vehicle and you end up with nothing. The file still, it has certain file size, but at the end, the content is missing. So we really need to understand the information loss. And the estimation of information loss is complicated because the file formats are complex, right? And then there are clearly dependencies, the file format and software and hardware dependencies that are unknown. So our objective is to design and prototype services for all of you that would kind of be living in the computational cloud, so you don't have to worry about where that conversion takes place. And it will also support some forward-looking decisions. Which file format I should go to, which software should I use for file format conversion. So what are the parameters of this, in this space? First, we have to decide what would be the file format and how many of them we can support. And as we know, content representation depends on a file format. We choose the software, whichever has the highest quality when we try to read the information or store the information. And then we choose certain hardware where we execute that particular file format conversion. And it might also be hardware that has certain I/O devices, input-output devices, storage media, and so forth. And then we have to define criteria for information loss. Because if I go to John Deere and Caterpillar, and they are telling me, oh, we are interested in 3D CAD models, we don't really care about animation. But if I go to Hollywood, Hollywood has all these 3D animations, but they care about the scene and the information about the background and illumination and so forth. So really the information loss is dependent, or the definition depends on the application. So the rest of the talk will try to show that we can have three types of services that could help people to deal with file format conversion. The first question is, can you find for me a file format conversion path or software that would convert my file to any other file format? The second question is, okay, now I found that path, can you execute that conversion for me? And the third problem is, okay, I converted my file, can you tell me how much information has been lost? So here are the technologies, and you can think of it like I'm standing here, right? This is the user. And the first thing what I'm doing, I'm asking a question. I have a file format A. Can I go to file format B? I submit that request and think of it like a cloud. There are some computers, and they will tell me, okay, use this particular conversion path. And then I go here and I say, oh, I upload my file, and somewhere in the cloud there is a computer that has that particular software that I need to execute. It will be executed multiple times because there might be multiple hops, multiple conversions, and it comes back the file, the converted file. And then I ask a question, okay, now I want to know how much information has been lost. I'll upload my file format, the original and the converted one, and it will give me back the comparison score, and it will tell me how much information was lost. There are clearly some challenges, and they are listed on the top. how would you automate the software execution? Because there are third-party software packages that we have no control over. How would you automate the execution? How would you make that scalable? Because if I give you 10 files, it's a very different problem than if I give you a million files. And then finally, how am I going to actually quantify that comparison? Right? When I look at these complex file formats like Adobe PDF, the example that I use, then I have to have some kind of a comprehensive file-to-file comparison scheme. Okay, so problem number one. We want to answer the question, find me the file format conversion software to convert from any file format to any other file format. We built this prototype called Conversion Software Registry, and it has support for searching, editing, and adding information about file format conversion software. It is completely open access. Everything that has been funded by the National Archives is open source. And it has login-based modifications because we don't want hackers to upload undesirable information. So here's the system, and I just made a movie of it, but you can go to that URL. You can see there is a list of software packages. The nodes of these graphs are the extensions of the file formats that it can support. The links show the conversion path. You can go and click, I want to go to this file format. Here I pick the source. It will tell me whether the connection exists. So if I want to find whether there is for this particular software, whether there is a connection or there is a conversion, then I can go and say, well, but I'm looking for a conversion between DXZ, which is a 3D CAD model, and to STEP. Well, tell me whether you can find anything that is up to 3 hops. And it says, no, there is no conversion path. You cannot go from that file format. Well, then I scratch my head and I'll say, well, maybe I can go from STEP to OBJ because that is the file type that I have right now. Tell me if there is something, and it will list for you that there is no direct conversion path, but there is a conversion path that takes maybe 2 hops, right? So I have to use Adobe 3D Reviewer and something else. Here is the list of all the software conversions that we have documented so far. There is 70 plus, I think, 72 packages with the help of the National Archives at the Rocket Center. And then also, we received some of the files that people might want to download and say, well, this is an example file. And we are trying to work with Georgia Tech to have some kind of validation in place. So I would have a set of files where I can say, if you download this file, we kind of guarantee that it follows the specification of, let's say, Adobe or a TIFF version 6.0. And then here I'm just showing that we can search by MIME type, we can search by extension, we can search by pronoun UID. There are still research challenges because, as some of you might know, when you go to pronoun, which is the UK file format repository, you will not find file format specification for every single file format. So what will happen if you go there and you get nothing, right? Then you have to come up with your own universal ID. And then everybody is going to have a kind of a different ID. So that's one challenge. The other challenge is that sometimes you have, let's say, .pic. I don't know how many of you are familiar with that file format. .pic extension has about, to my knowledge, more than 25 different MIME types. So there is no one-to-one mapping, and that might be a challenge. So at this point, we kind of are focusing on the software conversion and then finding the path, but people who are more interested in the file format identification have to address those additional issues. And then hopefully we can bring that together and then have sample files together with the file format conversion. Okay, so if we compare this system, the conversion software registry, with other systems, as I mentioned, there is a pronoun system for file format. It's a file format registry, and there is an effort in the US called Unified Digital Formats Registry, UDFR, before it was GDFR. And then when you do a survey of similar software registries or catalogs, they might be community specific, they might be very business oriented, but none of them would really have the import-export functionality. The closest one that we found was a project funded by the European Union called the Planet's Testbed. But when I checked it, it was password protected, so I couldn't really use it. and then it had only 18 software packages. So we kind of made it open because I believe that if companies even want to make money, they will just document their software. So if you, as an archivist, would like to find out, is there a software package that could convert my file format from A to B, you will be able to find it. Right? So that's the first problem. Can we find it? Okay, and then the novelty, as I said, existing file format registries focus on the file format specification. We are focusing on the file format conversion. And they are really catalogs of software because they want to sell the software or they want to serve their community, the scientific community. And the Planets one had only 16 software packages. It supports only single hop conversion. And I'm just showing here on the bottom what I mean by single hop or two hop, right? So single hop would be one link, but if I want to go from here to here, I have multiple hops, right? So it's 1, 2, 3. So actually this should be 3 hop conversion. So that's the novelty of the system. Okay, let's look at the problem number 2. Now we know the path, we want to execute that file format conversion. And I'll explain later why this is an enormous undertaking, but we kind of came to the conclusion that we have to use third-party software. And we built this system called Polyglot, and the version 1 is available. We are working on version 2. And the nice thing is that you can download it and install it on your server. And therefore, if you have classified information or you have some files that you don't want to upload to Google, because then Google is going to insert copyright on it, you can do it. So we are kind of building this open source system. If you want to use our resources, fine. If you have your own resources, that's fine too. And it's a web-based access to a computational cloud consisting of commodity hardware and installations of third-party software with import-export capabilities. And here is a quick movie. So you go to this, and then again you have this IO graph, and you say, oh, can I go from this file format to another file format? Here's the target. Yes, I found here is the path. I have to use 3 different software packages to go from WRL to OBJ. Oh, can I go from WRL to PDF? Oh yeah, you can do that using just Adobe 3D Reviewer. Now I go, I drag and drop, I have a file here. I drag and drop that file to the area, and I specify, okay, go to OBJ. On our server, at the execution, we are scripting the execution, and you can see here is the execution log. So what software was executed, whether it was executed successfully, and then you can download that file format. The other option is here I'm dragging and dropping another file, and I say go to PDF. You might not know that actually PDF now allows you to embed 3D. So when I convert that 3D CAD model of heart to PDF, I can go download that PDF file, and I can open that in the freely available Adobe viewer, and I'll show that soon. So here it is downloading the PDF file that I just created. I'll open that. And then here is my 3D CAD model embedded into PDF. And as you know, PDF has some manipulation or viewing tools. So if you click on it, it will launch a little applet, and then you can spin it around and then view it. So that's one way how you can view the result of your conversion. The other option is on top, you see these 3 different hyperlinks. If you go to the view mode, if you drag and drop file here and you upload it, we have support for certain file formats that you can view. So for example, this is a 3D CAD model, and again, there's an embedded applet that you can immediately preview the file that you converted. The same applies if we uploaded images or doc files or PDF files and so forth. So I'm going to say something about the architecture, and I know that from your perspective, probably I should talk much more about the services to archivists. But as I said, you can use this system. It's a prototype system. You can use it for finding the path. Can I go from, let's say, TIFF file to PDF file? If you find the path, then you can request the conversion. And then you can say, oh, I have 1,000 files in so many file formats. is this really the optimal conversion path? And for that, I have to evaluate the information loss. Or I can say, what should be my target file format? So I can pose some questions. The big box really just shows that that could happen in the cloud. You don't have to worry about it. And there are pieces that we build that are specifically focusing on computation scalability. If you tell us that you are going from million files to 10 million files, we'll just add more commercial off-the-shelf computers, stack them together, and we have a mechanism how to use a shared upload folder, and then the job is distributed across multiple computers. Automation, everything is based on simple scripts, so adding your software, if you have your favorite software, adding that would be just adding 2 lines. And you can see here, I'm sure that even some of you might have written a little piece of code that would do some conversion. Adding that code would just mean that we add to the table what software it is, what it can import, and what it can export. So the extensibility is very important. There are some existing file format conversion systems, but they support only certain conversion types. And the drawback is that they are not extensible. Whatever library they use, that's it. If you want to add your code, it's almost impossible. They cannot be downloaded for private use. So again, if you have classified information, you are not going to go to zanzar.com because you cannot. And then we don't know anything about computation scalability. We know, for example, what I heard is that New York Times hired Yahoo to do conversion of all the newspaper articles to PDF, and it was a large volume of data. And I don't know, I'm sure that Yahoo has figured out computational scalability, but we don't know anything about those other systems. So why are we doing this by reusing third-party software? Why are we not re-implementing everything because then we are confident that the quality is good? Well, because fully supporting the many available formats is an enormous undertaking. And many of the file formats are closed proprietary, and we have no access to them. They are complex, as I said. Some of the file formats have 1,200 pages specification. And then the vendors also use the file formats to store some specific pieces of information, and you would have no access to them. And then, but what we know is that many of the software packages out there also support some subsets. So if we put it together, suddenly all those subsets will overlap. Think of like a diagram where you can kind of bring everything together and you get the union of all the software packages. So really the software use and extensibility are the key characteristics of this file format conversion system that I'm talking about today. So, and then we do it by really utilizing whatever access the vendor gives us to the software. We use either the application programming interface, we use command line, and we have mechanisms how to script it. And sometimes we also talk about imposed code reuse. And imposed really means that the vendor who designed the software had never or didn't have the intention to share that code with someone else, right? So therefore we talk about imposed code reuse. And that's the novelty that more or less we can have a single user interface for you to all these conversion services that are executed automatically over a distributed set of computers, and they might have licenses. You know, each computer or each software might have a special license, so it has to sit on that particular computer. You have now suddenly access to all of them. And then also some of the conversions might require extra computing resources. Again, you don't have to worry about it. The computation scalability is taken care of. Okay, so let's look at the last problem, which is we converted the file. We want to know how much information has been lost. And the basic element of this is, how do I compare two files? And we built some initial prototypes for comparing 3D CAD models, so for comparing images. And we have been building this more generic application programming interface for anyone to add his own comparison method for two files. So let me show you an example. So let's suppose I want to compare these cat models. And just to make sure that they are similar, I took Adobe 3D Reviewer, started with this WRL file format, which is this red one. And then I converted it to STP, STL, IJS, U3D file formats. And then I just clicked on 3 of them. And it would compute the similarity of these 2 files based on light fields. It's a method that is used in computer vision, and it just takes the silhouettes from various viewing angles and starts to compare. And you can see that, and I think I have a conclusion here, that there is some information loss as you go from WRL to STEP. There is the same information loss as you go to STL, but it appears that Adobe 3D Reviewer dropped the same information because when you compare these 2 converted files, they are identical, or from the perspective of that comparison method. So it's kind of interesting to see that Adobe 3D Reviewer would drop some information as you convert it to STP and STL file formats. We don't know exactly what it is, but it probably drops the same piece of information. So that's a comparison example of 3D. Not trivial. There are many methods how to do it. Let's look at this system. I think I presented our initial prototype last year, where we compare PDF documents. So here I'm saying, well, the PDF has text. Let me first count the frequency of words. And here are the words, and then we decompose the words into only text and numbers. But the document has also images. So here's an image that's a logo of the Veterans Affairs Institute. And then it has also some tables. So here you can see that there are some lines in the document. So we let you preview the document differently than if you launch from this tool, the Adobe Reviewer. And then you can view what words and what images are there. And then you can select all these files and say how similar they are. And the dot here refers, the size of that refers to the similarity. And we can see that 3 and 4 are similar, 5 and 6 are very similar, and 1 and 2 are similar. And you can also, on the right side, you can say, well, when you compare these 2 documents, ignore certain words. Let's say the word end would be excluded. You can do the same about colors. You can say black color is the color of the background, exclude from the comparison. So it's a different way how you can look at these complex documents, because now you see more or less only the text, only the image, and only the vector graphics. And then you can identify those files that are identical. One example that we used, the Veterans Affairs documents came as Microsoft Word documents and as PDF documents that had almost identical file name, but they had sometimes _2. And we were tasked to find out whether some of these files are identical. So this was a very easy way for us to run the tool and then find what files are identical. Now we are working on a more complex approach where we know that if you take multiple files and you want to compare them, probably there are going to be many, many methods how to compare them. And those methods really depend on how you represent the data, what kind of characteristics or features you use, and then what will be the similarity metric. So in this case, I'm just showing that conceptually we have this prototype just for internal purposes, where we can load 2 images, or actually those images I created by starting with a TIFF file, converting that using Microsoft Paint, and then just doing pixel by pixel difference. And then because I can choose multiple methods here, I could get different results. And I can conclude, let's say, that the information loss when I go from the original TIFF file to BMP, or if I go from TIFF to PNG, was 0. So I didn't lose any information by doing that conversion. But if I go to GIF or JPEG, because these file formats introduce compression, it's a lossy compression, I'm going to lose some information. All right, so now let's suppose we want to evaluate information loss due to file format conversion. So I upload my set of files. I will say, these are the software packages that I have available. And these are my criteria for defining the criteria for defining information loss. Can you give me back the information loss score per file format conversion? And the way how we decided to do it is because we cannot support all possible file formats, we have to do a round-trip conversion. And then when it comes back, we say, okay, we started with JPEG, now it came back as JPEG, can I now do the comparison? So I first find all the round-trip conversion path in my input-output graph. Then I execute all possible conversions to obtain the converted files. And then I decide what metric I will use, and I will compare the original and converted files. And then I assign the score, the information loss score per file to each edge of my graph, or the conversion. So you can see this was one example that I was doing before I came here. I picked one file, which was in STP file format. I used Adobe 3D Reviewer and Cyberware Apply Tool, only 2 software packages. And I said, okay, how many paths do I have? I have 10 different paths in my graph, 28 individual conversions. They are listed here. In the second phase, I was running that, very CPU intensive. And then eventually I could assign a weight to some of these edges because I had the metric in place, and I could say how good is certain conversion path. So in summary, by doing this, we gain better understanding of preservation and reconstruction of electronic records in terms of file format conversion. The basic understanding was what should be the data model needed for documenting existing file format conversion software, which is the registry that we built. We also built some kind of a testbed or a framework for software reuse and extensibility to provide file format conversion services. And we also gain understanding how to deal with the complexity of performing content-based file comparison and also the measurement of information loss. It's not a trivial task. The computational cost I did not talk about, but on the back end we explored cluster computing using Hadoop. So some of these computations can be deployed maybe at the National Archives, and we can recommend certain hardware platforms. And we are currently looking at some specialized hardware like field programmable gate arrays, FPGAs, or GPUs, the graphics processing units. So what is the value for archivists? So these prototype services are freely available to digital preservation community. They can provide decision support tools for you. So you can perhaps select an optimal file format to be preserved, to evaluate file format conversion software, or maybe if you have some cost constraints, like some software can be more expensive than some other software. Maybe you have some machine which is idle and it's sitting somewhere, so another one is busy. Can you kind of find the minimum cost for a chosen file format conversion path? And the framework for conversion software documentation, software use, and functionality extensibility I believe has a major impact on efficiency with which we manage our holdings, which was my initial slide, which maps into the National Archives mission. It also has major impact on understanding of the information laws introduced by file format conversions, because as I said, most of you probably came to the conclusion that digital information is very dynamic. It cannot just sit there forever and you can view it down the road. You have to kind of migrate and keep it current, as the title of my talk indicates. And also, we in general, we have to understand the cost of updating file format conversion services. So our plan is to more or less keep these up and running. I would like to probably deploy the file format conversion services here at the National Archives or maybe at Rocket Center. So if you have some proprietary or classified file formats, you don't want to test it on our server, you can do it inside of the National Archives. It's all open source technology. If you have the expertise or you can get someone to help you with, we provide instructions how to download the software and install it. And then we have been building second generation of these file format conversion services, so hopefully they'll be better and better. Any feedback is very welcome, and I always appreciate if you just let me know, okay, Peter, this doesn't work. We also have a Jira system, which is a system where you can report your bugs or whatever you find out about our software doesn't work or you would like to have a feature added. So please feel free to visit these web pages and then let us know what you think. Thank you very much.
So with that, we will welcome all questions.
I'm very interested in the info loss score, and I think that's wonderful because it gives you a concrete way to help make some decisions about which path you might take. But can you talk a little bit more about the 3 criteria that would come up with that I got from that slide, which would be the feature extraction, the data representation, the similarity measure that comes up with the difference?
I have another funded project by the National Endowment for Humanity and the National Science Foundation and JISC, which is an equivalent to NEH in UK. And in that particular project, we work with images a lot, and we realized that there are many ways how you can quantify information loss, right? So I don't know how many of you are familiar with different distance metrics. You can use Euclidean, you can use Manhattan, you can use many, many ways how to compare 2 things, 2 objects. We don't know what metric is the best for you. Actually, I work with industry quite a bit, and they have their own custom metrics of success and information loss and so forth. So we just wanted to build a generic framework where you as an archivist would specify, I'm going to represent the data as 1D array of pixels, or 2D arrays because I have rows and columns. And it's up to you what software you use and how you want to represent. In addition, if you work with images, many of you know that there are multiple color spaces. So I can give you an image which has red, green, blue, but I can convert it into hue, saturation, value. Right? So the values are very different, the color space is different, and that all relates to data representation. Once I have that, once I selected that kind of a variable, then I say, how do I describe that image, that content? I'm looking at faces. Well, maybe it's going to be a histogram or a frequency of occurrence of colors because I'm looking at faces and I know that I should see skin color. And once you have that, then you say, oh, I want to use Euclidean distance or something. So that's conceptually, we are approaching that problem by saying, we let the users to choose the definition of information loss by decomposing that into these 3 criteria, and then you can choose how to do that. I probably should mention that we have some technical papers also available from our webpage, so if some of you are interested more in technical details, you are welcome to download the technical papers. One more comment I wanted to make is that the importance of having the code to be open source and extensible is that maybe you have a very unique piece of software that has a license, and nobody else has that license, right? So if you install that framework on your server, you add that software into our input-output graph, and now there is a script how to launch it. Now suddenly that unique software that can import and export files will be available to your entire organization. Or maybe if you open that to the outside, then it will be open to the outside. What we provide on our server, if you go and test out our Polyglot server, we could only provide access to open source software packages. And the only one which is currently there, and we are not sure what to do, is Adobe 3D Reviewer, because we had to pay Adobe for the license. But we are providing free services to everyone by using that licensed software. And I don't know what lawyers would say about it. I'd like to follow up on the example that Bob gave you, these 2 pieces of paper. If you take 2 files, you can look at the file size, and you will say, they are identical. That's what Bob did when he overlaid those 2 papers. But the content might be very different, right? So we care about the content, and we have to figure out how to compare them and what will be the information loss definition. Your question was really good about, how do I really compare 2 files? And I was at NIST on Tuesday giving a talk, and the example that I used, let's suppose there is a budget report where the National Archives would from the Congress would get, I don't know, $10 million, let's suppose. Somebody goes and there is one byte in the document and change the number from 10 to 100, let's suppose. When I compare those two documents, I see only one byte has changed, right? From 10 I went to 100. If I go to the same document and I replace the word attribute with the word feature, I made lots of changes, let's suppose. But the meaning might have not changed too much, right? So how do we really compare two documents and how do we evaluate the information loss? The value of that byte has very different meaning when we start to talk about 10 million or 100 million. That's a big difference. But the meaning of the document might not have changed when I use a synonym or something. So this is really critical, and I always talk, and I'm kind of always excited about talking to people that have different criteria for evaluating the information loss, because I think this is really hard for me, and that's the reason why I was showing that interface where we want you to be able to choose what is important to you. And as I said, Caterpillar and John Deere already told me, for them, in 3D CAD models, they have very different criteria than if I go to Hollywood and I talk to Pixar. The same 3D CAD model, but different aspects.
I echo the interest on information loss again. Is this framework actually record the loss? Because one of your slides actually shows if you try to convert a TIFF file to a GIF file, then the loss is bigger than the TIFF converting to a JPEG. And that's my first question. And second question, is there the process can be reversed? For example, like if I try to, my first version is converting from a TIFF file to a JPEG file. I decide on that, but then I provided the user for the JPEG file. Then if the user decides to convert from the JPEG to the TIFF, will there be another loss of the information? Is that making sense?
So there might and there might not be any loss, right? So if the starting point is the JPEG, the user receives, then depending on the quality of that software that the user is going to use, right, there might be or might not be, because we know that TIFF supports compression. It has LAMP-LZIO compression algorithm embedded. And if the user chooses a software package that is automatically compressing the data using the lossy compression, then there will be. But maybe the user has a different piece of software where he says, oh, just use the uncompressed file format representation, and there shouldn't be any loss. Now, we are talking only about pixels. But what about all the metadata that is like the tag? Because as you know, TIFF is a tagged file format, so there is a tag for creator, comments, and so forth. I actually found out that many of the software packages would drop completely all the metadata about creators, date, and so forth. So I think what I'm saying is that ideally, if you have a piece of software that you would like to know more about, just let me know if you are willing to share it with us. We will put it into the system and then you can run all kinds of studies. It's really, in my mind, it's a decision support tool for you to make the best investment. Because you are in charge of these very important decisions. What will be the file format that you want to convert to, or what will be the software that you will be using in-house? Right? And then, as you know, vendors will sell you everything for, you cannot trust the specifications all the time.
The agency that we work with, almost all of their records exist in either word processing software, mainstream stuff, or email. What would be the ideal format? And we'd like to not just convert it for what we're using today, but for long-term permanent storage, to just convert it one time. Obviously, plain text and ASCII and XML would be desired formats. But I just wanted you to comment a little bit about what would be the best method to take.
Let me answer this one first, Peter. This is a government question. The pieces that go with this is what I would basically say is that as basically research, one of the pieces that goes with the aspects of all of the government requirements for reliable, complete, authentic records. this research basically, provides a technical basis for judgment and decision. But the parts that go with, for example, the ultimate file format, or what is the aspects of all the regulatory and legal requirements that goes with record keeping. The one piece I would revert back to, and I'm not ducking your question, but goes with, this is a very specific tool that deals with what we've described as the very fast pace of the evolution of file formats. So all of the things that go with, for example, risk management, or all the pieces that would go with, for example, contributions to electronic record keeping, records management guidance, government policy, development activities. Potentially, the technical basis of this can form that. But the intent of this research is really not directed towards identifying the ultimate file format as much as it is with dealing with the very practical problems of, if you have, for example, a file format you cannot render, but you know that somewhere else on that graph you do have a tool that can render it. What is the appropriate conversions? Are there any? That's the first question. And also, what are the implications, including, for example, information loss? So that's the, it's not intended towards, for example, if I could, Peter, in the nature of things, if these are your source formats, and this is your destination formats, the key piece of that is also this research is not intended to define any of these as, in some senses, the ultimate file format, as much as it is the practical problem of, I have these formats in my collections, and I only have tools to render these formats. And what are the combinations I have to do to keep them accessible? Or virtually, again, if you've got stuff over here, the polarity is the same. Did you get my point? That's the key aspect of this.
Perhaps I can add to it by quoting what Ken Thibodeau said at the NIST workshop. He said, if somebody comes to you and says, oh, I know how much it's going to cost you to preserve this much data, or I know what will be the best file format for you, don't believe him. And why is that the case? Because the technology and the file formats and anything which is digital is evolving so quickly. There is just no way for us to predict maybe more than like 5 years down the road what will be around. So that's the reason why I entitled my presentation, Keeping Your Records Current, because somehow it becomes part of our daily life that we have to deal with those floppies that are, you don't have a drive for that anymore. You have to move it to CD, DVD, but tomorrow it will be Blu-ray disc, right, or something else. So I think the challenge is, what is the cost of keeping our files current? I wouldn't even pose the question, what is the best file format? I just have to live with the fact that I have to keep my records current, which is very different from paper copies, right? If you have a good air-conditioned room and so forth, the paper is going to survive for some years. And actually, I used to have a chart where a guy from Cleveland showed how long different media would live, would be around. That does not apply to digital information. That's my personal opinion. Maybe people in the audience have different opinion. But somehow, what I'm showing here is that we know that there is so much software out there. Actually, when we install many more software packages on our server that we cannot kind of give you access to because they have licenses, these graphs become so dense, you cannot even see a single line. And I think we see the value that in this very, very dense graph, there is no way for you or for a human to visually see, oh, there is a graph and I can convert it. Computers are really good at that. Computers are very good at finding the path, and once they find the path, if that conversion can happen for you, you don't have to worry about it, and your files are being current. Yes, please.
I have a few questions. I represent DoD in this type of activity. So I missed you at NIST. Mark Conrad told me to try to catch you, but I missed it.
Thank you, Paul. Thank you.
A couple of things is, even in the CAD environment, when the manufacturers or the vendors upgrade their version of CAD, data migration doesn't happen. So how do you track that? It's like in the PTC world, you go from 4 to 5, even though it's the same file name, it's not the same file. So how do you handle some of that issue?
So, as I talked about the file format identification, I said there is a mess in PUID, the pronoun universal ID, then you have the MIME types, and then you have the extensions, right? Because there is no one-to-one mapping. I cannot say that if I go to PUID and find that universal ID, then I will have only one MIME type, and I will have only one extension. When we actually validate some of the software here, and Mark Conrad was not here, but we asked his students to tell us and document the software which is in the conversion software registry. We said, ask your students to download the software, install it, run it, go to your file menu, and see what extensions it can import and export. That's the best that we can do. Now, let's suppose the file format extension says .pic. I still don't know what is that MIME type associated with the ext, because that software is telling me it's only PDF or .pic. I still don't know exactly which version of that file format specification is going to load. I have to try it. And therefore, when we were at NIST, we were talking about NIST taking or being in charge of building this repository of sample files. So now I can run a sample file which is uniquely defined. I know that this is MIME type X/25. I run it through that software that claims that can load PDF, and now I know exactly which version it can load. There is just not enough information about all these versions of file formats and versions of software, as you said.
Yep.
So I believe we need the test bed to really learn, because the documentation is not there and nobody knows.
I have a question directly relates to what he just brought up, but just regardless of file extensions, how common is it for all these different proprietary file types to have a signature in the digital blob that is the file? Usually you can determine what kind of version of software was used and what type of file it is just by looking at like a hex dump or something like that. How common is that to be able to identify stuff regardless of an extension?
I would like to defer that question to one of the research partners at Georgia Tech, who is specifically focusing on the magic numbers and the unique identifiers. We have looked at that, and I think it goes back to the software and file format there is a very close link. One of the most successful file formats is HDF, and the reason for that is that they provide the code, the implementation, with the file format specification, as opposed to ISO standard like STEP, which has 1,200 pages of specification, but nobody has the implementation, and therefore, whatever version of the STEP file format reader you get, it will never have all the components and all the support. So now going back to your magic number or the unique identification. In my file format loader, my software, I modify one line of the code. Should I immediately issue a change of the MIME type because it's a new file that I will generate? I just change something in the code. Maybe it will change something in that file format representation. Who is going to keep track of all the software changes and the data sets that were generated as the software has been modified? Are you going to assign unique identifier to that file format that was generated, which is associated with the time snapshot of that software that generated? And now you have 10,000 implementations of the same file format times 10,000 changes, and now you have so many versions of unique identifiers. It's just impossible. So that's my perspective, but I'm not the person who really works on that aspect. It's really beyond the blue.
The other thing I would say is, in the nature of just my own technical observations, and with all respect, the answer to your question is both yes and also no. There are instances where actual formal signatures are part of the format definition specs, and they are applied. There are also many instances where they're not, and there's also, as Peter mentioned, one or several of the related activities that we look at in terms of technical rigor is really the aspect of identifying file formats I believe, is very much a matter of reflecting the evolution of software and file formats over time. Where, in some cases, the very traditional approach is those of you who are, who follow this kind of work, will say that there's actually a feature in Unix that's been around for over 20 years that I know of. It's called magic numbers. The magic number approach is not comprehensive or complete, in basically both ways. There's file formats that are not, in the terms of a file header, there's a number that in many cases appears, and there's relationships that appear basically in files that tell you what kind of file it is. That's how viewers work. And that's how an application tells you basically how the application should render the format. There are cases basically where those numbers are not there. They were not part of the original development. There's also cases where, because of the development of technology, they're not always correct. There's also MIME types, which is another part, but again, the answer is not complete. There's pieces that people have tried different approaches, including, as you said, signatures. In some cases, people actually will embed a digital hash and stick it in the file, basically as a technical confirmation of what follows. But the point is it's not exclusive and not inclusive in government. There's even things, for example, one of my favorite examples in this area is several years ago I had the privilege of working on some files from the systems supporting the President of the United States. In those particular systems, one of the very common examples of an extension is files were suffixed by the PRS, .PRS. Very simple example. In the context of general computing, if I remember correctly, that's actually is a printer script trigger for if you use computing technology of 10 or so years ago. PRS, most computer people would look at it and they say, well, that contributes to control a printer. In the very unique places of the operations involving computers around the American president, PRS meant president. So the question is if you look at these things and you would look at these files, and if you used a very, very generic tool, what you would find was that basically the tools are tricked. Just because, it's just an arbitrary thing, people would look at it and look at it and say, well, they were expecting a printer script, and they didn't get it. What they actually got was a document that was created to support the president. Another one is JPEG. People will use their initials, and if their initials happen to be the equivalent of JPEG, you can't use the JPEG extension. But there's all kinds of things that basically, the approach that I would say in it is also the part where this is one where the extension of the discussions that people have had for decades about this are today very well served with these kind of very specific experiments. Because it comes down to is what I believe is technical rigor that also provides for scale. Because as Peter mentioned, a lot of this work targets very, very large collections. So the opportunity for a human to make the decision every time becomes problematic. No matter how good they are, it may be too slow. Did that answer your...
Yes.